So let's take a look at Taylor and Maclaurin polynomials. Now the formula for a Taylor polynomial is f of a plus f prime of a times x minus a over 1 factorial plus f double prime of a times x minus a squared over 2 factorial plus f triple prime of a times x minus a cubed over 3 factorial, and so forth. So keep in mind that a is going to be the center of the polynomial. So wherever the polynomial is centered, at what x value, that is going to be the a value. And so for Maclaurin polynomials now, Maclaurin is a form of Taylor, but it's centered at 0. So the a value will be 0. So the formula will be f of 0 plus f prime of 0 times x over 1 factorial plus f double prime of 0 times x squared over 2 factorial and f triple prime of 0 times x cubed over 3 factorial, and so forth. So keep in mind that these are approximations. So whenever you're trying to approximate, let's say we're trying to approximate sine of x, we have to say sine of x and use the approximate equal sign, so use the squiggly lines. And also, when it asks to estimate to a certain degree, let's say the degree is 2, then we're going to go to the second derivative. If it asks to approximate at 3 degrees, third derivative, and so forth. So for number 1, we have to find the Taylor polynomial of 2 degrees centered at the given point. So we have sine of 2x, and the center is at pi over 2. Notice how it says degree of 2, meaning we must go to the second derivative. So if I were to write out the formula, once again, we have f of a plus f prime of a times x minus a over 1 factorial. And I'm going to the second degree, so I'll just write up to the second derivative. So f double prime of a times x minus a squared over 2 factorial. So this is the formula for the up to the second degree. Now notice how we need to evaluate f of a, f prime of a, and f double prime of a. So in order to do that, we just need to take the derivative. But first, in order to evaluate f of a, we can just plug in pi over 2 into our f of x function. So if f of x, once again, equals sine of 2x, then f of pi over 2 is going to equal sine of 2 times pi over 2, or sine of pi, which is equal to 0. So f of x, or f of pi over 2, is equal to 0. So now let's find f prime of x. So the derivative of sine of 2x is just going to be 2 cosine of 2x. So then f prime of pi over 2 is going to be equal to 2 times cosine of 2 times pi over 2, which is just pi. Cosine of pi is -1, and -1 times 2 is equal to -2. So that will be f prime of pi over 2. Since we need to go to the second degree, we'll do one more. So f double prime of x. Derivative of cosine is negative sine. So the derivative of 2 cosine 2x is going to be -4 sine of 2x. And so f double prime of pi over 2 is going to equal to -4 times sine of 2 times pi over 2, or sine of pi. Sine of pi is obviously 0, and -4 times 0 is still 0. So that will be what f double prime of pi over 2 equals. So now we can write our formula. So obviously first we need f of a, and we are going to approximate sine of 2x. So I'm going to write sine of 2x, and remember this is an approximation, so we're going to write the squiggly equal sign. It's going to equal to f of a, so f of a is obviously 0, because f of pi over 2 is 0, plus f prime of a times x minus a. F prime of a, remember, we got is -2. So we'll do -2 times x minus a. So x minus our center point. Our center point is once again pi over 2. Over 1 factorial. plus f double prime of a, f double prime is 0, times x minus a is pi over 2, obviously, squared over 2 factorial. Notice how we have zeros here and here, so the entire thing can be canceled, and so we're left with 1 factorial is obviously just 1. So sine of 2x is going to be equal to, or going to be approximated to, negative 2 times x minus pi over 2. So now let's say for number 2 we have to find the Maclaurin series of degree 2 of f of x equals ln of 1 plus x. Now notice we have the second degree, so we need to go to the second derivative, and we're doing a Maclaurin this time. So the center is automatically going to be at 0. So the Maclaurin series, once again, is going to be f of 0 plus f prime of 0 times x over 1 factorial plus f double prime of 0 times x squared over 2 factorial. So we need to first evaluate what f of 0 equals. So we can simply just plug in 0 for x. So then f of 0 is going to be equal to the natural log of 1 plus 0, which is 1, and the natural log of 1 is obviously 0. So now let's find f prime of x and plug in 0 for x. F prime, so the derivative of a natural log of 1 plus x is just going to be 1 over 1 plus x. And so when I plug in 0, f prime of 0 is going to be equal to 1 over 1 plus 0, which is 1, or simply just 1. And if I find the second derivative, so I'm going to rewrite 1 over 1 plus x as 1 plus x to the negative first, because now it's easier to use the power rule to derive. So then f double prime of x is going to be equal to negative 1 times 1 plus x to the negative second power, or negative 1 over 1 plus x squared. So then when I plug in 0, f double prime of 0 is going to be equal to negative 1 over 1 plus 0, which is 1 squared, which is 1. So we'll get negative 1. So now let's just write out the approximation. So the natural log of 1 plus x is going to be approximated to f of 0, which is obviously 0, plus f prime of 0, which is 1, times x over 1 factorial, plus f double prime of 0, which is negative 1, times x squared over 2 factorial. And finally, if I were to simplify this, the 0 will go away, so I'll just get 1x over 1 factorial, which is just x, minus x squared over 2 factorial, which is 2.